As a developer, there's nothing I love more than ignoring the 150,000 existing solutions to something and building one from scratch myself. I'm sure many of you watching along will be in the same boat. But doing so comes with trade-offs, some good, some bad, and that is what this session is all about. Your next speaker of the 2021 CityJS conference is Francesco from Treviso in Italy. Francesco is a developer and partner at Flowing, and in this talk Francesco is going to be looking at rendering engines, more specifically comparing a rendering engine built from scratch to that in React to understand better how they work, as well as the trade-offs that both sides come with. This is sure to be an interesting talk, and if you are manipulating the DOM, which I guess is pretty much everyone here, then this is going to be a good talk for you to listen closely to. Learn from Francesco's mistakes. If you have any questions about any of the content in this talk, please do save them for the Q&A session, which will be happening straight after this session. And as always, keep posting along on social media using the hashtag CityJS2021, as well as keep your comments coming in the comment section wherever you are watching. Francesco, it is my pleasure to hand the conference stage over to you.
Hi everybody, and welcome to this talk called A Do-It-Yourself Guide to Building Your Own Rendering Engine. As you will imagine, we're going to talk how to work effectively without frameworks when building a rendering engine for your JavaScript front-end application. If you're interested in more content and more reasoning about working effectively without frameworks, I suggest you to check it out, the frameworkless movement. You can do that at frameworklessmovement.org, where we have a manifesto and also a GitHub that hosts an awesome list of content about frameworkless. I like to start my talks with the reason of the existence of the talk, what I call start with why. So why should you learn how to build the rendering engine? Or why should you listen to me in this talk? Why it's interesting for a front-end developer to build a rendering engine. And I wanted to do that telling you a story, my personal journey with rendering engine without frameworks. And I assure you that I will keep it short, okay? But it's important to understand how I arrived to these conclusions. 7 years ago, and I think 7 or 8 years ago, my team and I had to modernize a front-end application on top of an old Java framework. In a nutshell, we had a Java framework that produced HTML and some small JavaScript with a very, very little interactivity. It was not a single-page application, okay? Our purpose as a team was to add on top of that some JavaScript to make it in a full-fledged IX application. So to add DOM manipulation, to add interactivity, to make it feel a modern application. I know I can't see your faces because we are remotely, but I think that this is your expression now. And this was my expression at the time. But it is going better because we couldn't add new dependencies in that project. Or better, we could do that, but we had to talk with our client's team. That team should talk with their tech lead. The tech lead should talk with the senior architect, and the senior architect should talk with the CTO. And then a CTO should send an email when he said, oh, cool, you can add Redux in your project. So it was too cumbersome, so we can't really add the new dependencies. It's going better, right? Really? Okay, but it's not finished yet because the main point was that the only available libraries were jQuery and underscore. That was everything we had at the time. Okay, it's gonna explode. That was my first thought when I started working. And I was right, because we delivered the project, we delivered it also on time, but as you can imagine, my team and I were very, very unhappy. And we were unhappy because the code was very messy. Okay, we used the expression spaghetti code, and trust me, I'm saying that as an Italian. This is a very, very bad photo of spaghetti. So just to let you know how I felt when looking at the code, it was a mess. It was a big bowl of mud. It was a very, very awful spaghetti code. It was awful because every JavaScript developer knows that you never have to manipulate the DOM. This is like a dogma that every JavaScript developer keeps saying to themselves. And when I asked my colleague why it didn't work, they answered me, because never manipulate the DOM. You have never like a, like a shunt or something like that. But we should never manipulate the DOM because manipulating DOM is hard. And so we use frameworks to create and manipulate the DOM. Okay, I know that it's obvious, but I wanted to remark that because I know that it's hard, but I think that if you want to be an expert front-end developer and if you want to deeply understand how to work effectively in any kind of situation, manipulating the DOM is an important part of your job. This is my point of view. And this is what I learned because after that awful experience, I worked in other contexts when I have to manipulate the DOM directly without the use of frameworks. And after a while, I get used to it. And I started working effectively also without framework when working in front-end application. So let's do it. The point of this talk is to try to help you in understand how to do that, and most importantly, when to do that and how to do that in a correct way. Before taking a look at the code, I want to share with you the principles that should drive you when you start writing a frameworkless rendering engine. The first and most important principle is to choose a simple architecture. With simple, I don't mean easy. Simple means that is the right thing to do. An example of a simple architecture for a rendering engine is this one, that the view is a pure function of the state. We will see in a moment how to implement that, but this way of thinking is really simple. It does not mean that it's easy, but it's simple. Another important principle is called YAGNI, or if you want to spell it out loud, is you aren't gonna need it. It's a generic programming principle that states that you don't have to overthink and overdesign stuff. You just need to solve your specific problem in that specific context, in that specific time. You don't have to build a new framework from scratch if you are decided to work without frameworks. But you need to build just the thing that you need to solve your problem. Another important principle is that premature optimization is the root of all evil. This is a quote from Donald Knuth. This is a standard principle in software engineering, but when it comes to front-end, there is a problem with this principle because as front-ender, we are told that performance is UX. So it's an important part of the experience that our user feel with our products. So as an engineer, I know that premature optimization is evil. As a front-ender, I know that the performance is usually important for our customer, for our users. So it's quite confusing for us front-enders. So my point is that you don't have to care immediately about performance. You need to build your architecture not caring too much about performance, but you have to measure. You have to measure constantly performances. One of the ways that I use to measure performances is with stats.js. is a simple tool for Mr. Dupe, the creator of Free.js, that you can inject in any front-end application, and you can measure the frame per second, the latency, the RAM occupied, and also other stuff. So you can build your architecture, your framework if you want, without caring too much about performances, but you have to keep them under control and to intervene if performances start to drop. That's it. The last principle is what I call eat the frog. With eat the frog, I mean that you have to solve immediately the most important problem. If you have ahead of you a bunch of user story in your backlog, and you have to build something from scratch without frameworks, you have to tackle the biggest problem immediately in order to let your code withstand smaller problems. Okay, that's it with the principles. I would like to show you the code, an example of a rendering engine built without the help of any framework. The code is available on GitHub, and I will share with you the slides after the talk, so you can grab it here. But the demo is just a simple to-do MVC application. It's a to-do list that every 5 seconds generate a new random list of elements, and will repaint everything from scratch, okay? In this application, we have 3 important elements that change during time. That is the to-do list, the to-dos, the elements. Then we have the counter. You can see 2 items left. And then we have the filters, all activated and completed. That's it. Okay, let's take a look at the code. Let's start with index.html, the skeleton of our application. This is a standard markup of a to-do MVC application, but you have to notice there are 3 elements with strange data attributes. And I say this one: data components to-dos, data component counter, data component filter. This is our the entry point of our framework to manipulate the DOM. I tag the element of HTML with a custom attribute called data component. The attribute of the component is the name of the component itself. That's it for the HTML. We are going to use, as you will see, the markup of any element as a stamp, like the initial state of the component. Well, okay, let's go to the code. Let's skip for now the imports, but let's talk about actual code. Okay, first thing first, we define a state, the state of our application. And I say that the state of our application is an object formed by to-dos, that is an array of to-dos generated randomly with Figure.js in this case. And then I have the current filter that is simply the string all, because it's the first filter in the to-do MVC. Then I use component registry that is a custom object that I created, and I will see the code. I will show you the code in a moment. And then I add to this registry 3 components called to-dos, counter, and filters. Probably you notice that the name are exactly the same of the data component attribute: to-dos, counter, and filters. This means that the code that will manage the UL is to-dos component. The code that will manage the span will be counter component, and the component that will manage the second UL about filters is called filters component. Then I create a render function that will wait for next request animation frame, will take all the document, it will take the section, okay? It will select the section. This is from the real DOM. Then our component registry has another public method called render that takes the original DOM element, it takes the state, and it will return a new component, a new DOM element, virtual DOM element, completely unrelated from the real DOM, that is a copy of the main component modified by the state. As you will remember from the slides, our view is a pure function of the state. This is the core of our simpler architecture. Okay, now I have a document body, I have a real DOM node, and I have a virtual DOM node. With the function apply to DOM, what I do is to apply all the difference to the main container, the object in the DOM, to make them identical to the new main component that is a virtual element. This is very similar to what happens with React, for example. Of course, my code of apply to DOM, I will show you that in a moment, it's way simpler than the code of React. But what I'm interested in here now is the logic behind it, okay? So I create DOM elements in a virtual state with a pure function, and then I apply them to the DOM with an imperative function. That's it. This is the core of my rendering engine. Then I invoke the render to do the first rendering, and then every 5 seconds, I change the state and I render again. In this talk, I will just focus on rendering the data. What you need to create a full application are other 2 elements. The first one is an event, a DOM event library or something like that to manipulate the events from the user, like the click or the inputs, to manipulate the state, and a state management piece of code to render again the application when the state change. For now, for this talk, for the sake of brevity, of course, we'll just simulate them with a set interval. So let's take a look at the rest of the code. Let's start with the components. In this scenario, a component is always a simple function, a pure function, that takes an original element and the state. In this case, my target element will be the UL, for example, or the UL of the to-dos, this one, and the state, I just take the to-dos for this component. I use object destructuring to take the state, the to-dos from the state. First thing first, I clone the node. So I create a virtual DOM node cloned from the original. And then I use a map function to create a list of li element to put them in the to-do list. The to-do element is a simple function that takes a to-do. A to-do is just an element that has a text and a completed status. And then it uses these 2 variables to print down a well-formatted li to put in the DOM. Filters, it's very similar as a structure, as the same signature. It takes the target element and part of the state, but it's easier because it manipulates a copy, removing or adding the selected class. The counter, it's even more easier because I get the span and I simply change the text content with the caret label. That's it. So this is the code of the element that form my registry of components. Let's take a look at the registry code. A registry is nothing more of a simple JavaScript object when the name of the component is the name that we use in the data component, and the value of the object will be the actual component, almost the actual component, because let's take a look at the 2 public methods of the registry. We have add and we have render. If you see the add method, we put in the registry not the actual component, but we wrap it with an high order function. We wrap our component with something more complex, and I will show you in a moment what it is. The random wrapper takes a component that, remember, is a function of the target element and of the state, and return another function with the same signature, and so target element state, and follow me in what this function does. I invoke the component. So for example, with the to-dos, I invoke this one. So I create a new UL taken from the state that is virtual. Okay. Then I take all the children of the component that I just created that has the data component attribute. And then for every one of them, I look for the component with that name. Imagine that we have to-dos. Registry to-dos is something that exists. And if it exists, I replace the child element with the result of child component. In this way, I have, for every component, I have a recursive component that searches for other component in itself. Then the render, the starting of our application, is just a pure function of a root element and state. I create just a simple cloning function, and then I wrap the root and invoke it. What is happening under the hood is that I will clone everything, and I create a new virtual DOM element. Then I look for data components. I look for to-dos. I find the to-dos component, and then I will replace the empty UL with the result of this function. And then I will do that also for filters and for counter, and so on and so forth. After I executed my code, I will have a new DOM element that I will apply to the DOM with apply to DOM. Apply to DOM is a simple imperative function that it will take a parent node, that is the default is the body. It takes the real node from the DOM, and it takes a virtual DOM node that we should apply to the DOM. So we have this kind of situation. If I have a real node, but I don't have a virtual node, I have to remove it. If I don't have a real node and I have a virtual node, I have to add the virtual node to a parent node. If there is any difference between the virtual node and the real node, I simply replace the real node with the virtual node. And then I do that, the same algorithm for every children of the real node of the virtual node. In this way, I create a recursive mechanism. To check if a node is changed, I simply check if they have different tag name, or if they have different number of attributes, or if they have any different attributes, or again, if they have different text content. Otherwise, they are the same, and I skip the replacing. That's it. This is my frameworkless rendering engine. If you sum the line of code of the registry and the line of code of apply to DOM without white spaces, you will get around 100 lines of code. So as you just saw, it's quite a simple rendering engine. Okay, I want to close my talk telling you what I learned during my journey in these years of frameworkless code in a front-end application. The first thing that I just learned is that a rendering engine can live in harmony with a framework. It's not a black or white situation, okay? You don't have to decide from the beginning if you want to build everything without frameworks or everything with a framework. The two approaches can live together in harmony. So you can say, I want to use React for the 90% of my code, but there are some specific pieces of code that I want to do in a frameworkless way because I want to achieve something else. I want to own all the code of that specific feature that I want to implement. This approach is particularly good when you have to work with legacy code. In these last 5 years, I worked with a lot of legacy frameworks like AngularJS, Backbone, or jQuery. When team struggles to work with legacy framework, what they usually do is to add another framework on the top of it. This approach is quite disastrous most of the times because you have a very old framework with its life cycle, and you add another framework on top of it with a different life cycle. The two things together usually don't match so well. On the other hand, if you have an old framework that you want to get rid of, you can inject in the old application a lot of new code built without frameworks, because you can arrange the true life cycle of the two framework, or the original framework and your actual code that you want to write anew. In this scenario, after a while, the old framework will just be an empty shell, and it will be easier to replace with something else. Well then, how to decide if this is a good solution for your team? I'm sorry for you, but this is a $1 million question. You will not get an easy answer from me. But what I did in these years, after that I studied a lot of frameworkless front-end development and decision making, is to write 2 books. On the left, you have the frameworkless front-end development from a press that I wrote last year in 2019, if I remember correctly. That is a manual about working effectively without frameworks in JavaScript. You will learn, reading the book, how to make a rendering engine, for example. The code that you just saw is taken from my book, or managing events, state management, routing, HTTP requests, all without frameworks. The second book, Decision Making for Software Developer Teams, that I'm currently writing, but that you can start reading now because it's on LinkPub, and it's edited by Avas Coperta. It's a more theoretical book, and it talk about how to help team in making technical and also non-technical decisions, like choosing a framework or choosing to not use a framework, choosing the next feature, or choosing the right architecture for the right project. If you want to contact me, I suggest you to follow me on Twitter, because it's the only social network that I really use. And if you have any inquiries or question or feedback about what you just saw in the talk, you can write me direct messages, because they are open, and I will try to answer fastest I can. Thank you very much.
Francesco, that was a brilliant talk. Thank you very much for delivering it as part of this year's conference. It was super insightful to get some more understanding around rendering engines and how they impact our applications. Really, really great stuff. Thank you for delivering it as part of this year's conference. I'm sure our audience will be joining me right now in giving you a round the world round of applause. Francesco's Q&A will be starting over on GatherTown any moment now, so please do join us there. If you have any questions about frameworkless rendering engines, I'm sure Francesco will be more than happy to answer them. If you enjoyed that talk, do let us know on social media using the hashtag CityJS2021, as well as keep the YouTube comments rolling in. Francesco, thank you very much for that amazing talk. I think in honor of our AV problems, we should freeze momentarily.
Sorry. Sorry
You
about
see,
that.
no, don't apologize. These things happen. The content came through, the slides came through, the audio came through. We had all the
Perfect.
important
Okay.
stuff.
Okay. It's more important than my face, so it's okay with
Well,
that.
in that instance, yes, definitely. So we've had a couple of questions come in, so I'm going to get right into the thick of it, and then we'll just see where this leads us.
Okay.
Someone's asked for a clarification as to what a pure function is, keeping in mind that we've got lots of juniors and newbies to the industry
Okay.
here.
A pure function is a function that where the result of the function is it depends just on the input parameters. It doesn't not modify the object that you receive. If you saw my code, I say that the new DOM that I created is always a copy of the old DOM. So I never modify my parameter inside. This is called a pure function. It's a mathematical concept, for example, sine and cosine. Okay, they don't modify the value; they just return the result.
Yeah, perfect explanation there. I hope that that answered the question in that we had come in. Another one was, have you ever heard of chew.js?
Yeah, I never tried it because but I heard about them. But the point is that it's not the fact that it's a tiny framework that is cool. The main point is that sometimes you have to build something all the smallest possible for your code. But not about performances or bundle, but because you have to own that code. That's the point. So
Okay.
it was 100 lines of code or something like that. So
Yeah,
it's very small.
it is very, very, that's for a framework, that is very, very small. Very, very extendable though, I would guess at that size. So another one. How do you handle event listeners? Replacing a node will not deregister existing ones, which will lead to a memory leak. So how do you handle event listeners with that in mind?
Oh, I don't remember the name of the technique, so I will explain how it works, but I don't remember, sorry. What I do is that I attach all the event listener to the body of the application. It's like a trick, okay? All the listeners are not on the buttons or the input, but everything is on the main body that will never die, okay? And then I use a mechanism of like regex to match that you wanted to attach to the right button, the right event listener. So you don't create and remove event listener, and so you don't have memory leak in that case.
Well, that's a really smart way of handling it. I've never thought of doing it.
I think that React work with this technique, but I can't catch the. I think it's called event delegate because you delegate the event handler to your parent or something like that.
Yeah,
But I'm not sure.
you let it bubble up and all
But
those
yeah,
kind of
exactly.
words. Okay, another one here. Have you considered applying such a framework to SVG? In my experience, SVG is underrated and more powerful than developers might.
Yeah, exactly. Well, I created something like that to create a custom chart for a bank a couple of years ago.
Okay.
Because if I remember correctly, one of our designers decided to build a chart, a pie chart with the form of a diamond. Okay, you have slices of a diamond for a pie chart, and I have to manipulate SVG, but SVG is XML. And so I use the same technique to manipulate the data, and from the data, I have a new version of my SVG. Just like D3, I think works in this way. But that code is way simple if you just saw. So yes, correctly. SVG, it's underrated also in my opinion.
Okay, so what would be a extension of that? How are developers not using SVG in a way that you think they could be?
Oh, I think that SVG could be cool to use for some kind of interactive elements like menus or something like that. I think that I suggest you to read a very cool book called SVG Animation by
Okay.
Sarah Dresner. It's very cool. And it explains a lot how this stuff works under the hood. And then when you gather how that work, you can manipulate them just like any other HTML. So it's feasible.
Mm. Okay. I'm glad you mentioned that book because it's on my birthday wish list, which I'm
Oh,
hoping.
okay. It's a good
Uh,
book.
if
My
you're
camera
listening in,
froze.
Sophie, hint, hint.
Okay.
Um, so what I'm interested in making sure we explore as part of this conference is that a direction of junior developers and people new to the industry. So do you think that going through the exercise of creating your own framework for somebody who's completely new and learning as they're doing it is a good one? Or do you think that they should go and dip their toes into Vue.js, Angular, and all those
Um,
kind of things first?
uh, okay, let me think about it. It's a good question. I think that juniors should start with frameworks to learn the principles. Because if you think about the code that I show in my talk, it's in a way similar to React.
Mm.
And I don't mean the code. Of course, the code of React is way, way more complex. But uh, the reasoning behind is similar to React, okay? But to arrive to this kind of conclusion, you need to know quite well frameworks.
Okay.
So my point is that if you're a junior, you need to learn the principles using the frameworks. But after a while, you need to get your hand dirty, okay? And say, okay, and what I can do without it.
Yeah.
At the beginning, it will be a mess. Because when I started working without frameworks, I was not a junior. I was already a senior developer, but it was a mess in any case. So it's okay, but I think that it is a process, and you should start with framework. Framework are a very, very good way to learning principles.
And I think what you said just echoed what Maya said in the previous Q&A, which was you need to understand why things are done, not just how to
Exactly,
implement things. And that sounds
exactly,
like what you're saying. You understand how a framework does it and why they do it, and then you can apply it. If you don't know that,
exactly. Because when you understand why, uh, and when you learn, because it's a difficult thing, to not overthinking, but just to solve your problem, the code becomes simple to write down. But you have to understand the principle behind decision of other developers. I mean, the developers of the frameworks in this case.
yeah. So did you create a bunch of state charts for your framework that you've just created, or did you just dive straight into the code? Because Maya might tell you off if it was the latter, I will admit.
No. It's I don't like to create frameworks, because if I need to create a framework, I take a new one. I take a framework from somebody else that do the work. But what I do is that I have a lot of middlewares, if you want, small pieces of code like the one that I show you, and I use them in real life project when I am in some strange use case, or when I need to own all the code, for example. That's the point. I don't create framework from scratch, because I think that there are better people than me to create frameworks. Okay, there are people that have their main focus is to create frameworks. My focus is to build products.
Yeah. What kind of products are you working on at the moment? Anything exciting?
It depends. I'm working on right now. I'm working a lot on application modernization. So I'm taking sometimes old ERP or business software, and we put it with our company in the modern world. Okay, we rebuild them usually from the UI, and then also from the refactoring and all the stuff. I like it, but it's not exciting for everyone. It
No,
depends.
but I think diving into existing code bases is good fun. It's like archaeology, isn't it? You,
Yeah, but also, it's not always old code. Sometimes we add a new feature on a new code, but you have to do that also with new user research, user interface. So it's quite a difficult task, in my opinion, but I like it.
okay. I like it. I like that answer. It's a good answer. Good answer. We're rapidly approaching the end of our Q&A time, and we've got some rapid fire questions that we're answering asking every single speaker, as well as a couple bespoke just for you. So we'll start with the big one first, and then we'll work our way through. Tabs or spaces?
Oh, I don't care. I use standard JS or SLint. I don't care. The important thing is that somebody else will decide that for me. I don't want to discuss this stuff.
I like that.
Point.
Outsource that decision. Brilliant.
Yeah.
Love
So
it.
the point is that there is some rule in the project. No, okay, I take the first rule that I found on GitHub and put in the project. I don't want to talk about it. I don't care.
Well, on that note, we'll move on to the next question.
Yeah, exactly.
Front end or back end?
Okay, this is more difficult because I am a front-end engineer, but I'm not good, for example, with CSS. I don't know, I never get to learn the CSS. So what I do is that in a project, usually I do most of my time on the front end, but I work also a lot on the Java backend, Java Node or Kotlin backend, and yeah. I'm a middleman. Okay, I'm not quite as good as a front-end engineer because I can cover CSS.
Yeah,
but I can also work on the other part of the stack. So I don't. I prefer front-end. I'm a more expert in front-end development, but I don't care working also in other languages.
You don't care about a lot, really, do you?
Yeah, yeah,
It's
exactly.
good. This one you'll care about: pasta or pizza?
Pasta.
Pasta.
Pasta, but it's hard. It's hard, but pasta.
Good man.
Yeah,
if you had to pick one to work with forever for the rest of your life, Angular, React, or Vue?
I choose React because React it's smaller. Okay, React is you can adapt React to your needs more than Angular or Vue, in my opinion, because Angular and Vue are complete frameworks.
Yeah.
React it's a framework, but it's you can adapt it better to strange use case, in my opinion.
Okay. And finally, apples or bananas?
Bananas all the way.
Good man. I think you're the only person who said banana so far. I like that.
I love bananas.
Francesco, it has been amazing to talk to you, and thank you for that brilliant talk as well. It's one I'm looking forward to going back and revisiting afterwards. I think there's a lot in there I'll be able to take away from it. If you're watching along at home, please don't forget to visit the sponsor booths. You never know what they're going to be handing out. Make sure you go and visit the Auth0 booth. I think they've got some pretty amazing stuff there for you. Francesco, once again, thank you very much for being a part of this year's conference. Ciao.
Bye-bye.